The mist hung thick over the French countryside that September morning in 1944. Near the village of Ericourt, visibility dropped to mere yards. First Lieutenant Merwin Mastern felt the cold metal of his Sherman tank's turret rim beneath his fingers. His breath formed small clouds in the damp air. Inside the tank, his gunner squinted through the periscope. The glass was fogged. He wiped it clean repeatedly. The terrain ahead remained shrouded in gray. Intelligence reports had arrived the night before. Panthers were in the area. These German tanks had earned a fearsome reputation. Their thick, sloped armor deflected most American shells. They bounced off like pebbles thrown at a fortress wall. What Mastern couldn't know was the secret hidden in his ammunition storage. 6 rounds that would change everything. 6 M93 high-velocity armor-piercing rounds waited in the darkness. Inside each round lived a tungsten carbide core. This material was harder than steel, harder than most substances on Earth. These cores could transform an ordinary Sherman into something German tank crews would learn to fear. The mental impact would prove as deadly as the physical destruction. German assumptions about American weakness were about to shatter. Panther invulnerability would become a myth. This transformation began not in the fog-covered fields of France, but in American factories and testing grounds. There, metallurgy experts and ballistics engineers raced against time. They faced a problem that threatened to cripple American armored operations across Europe. Early 1944 had brought unwelcome revelations to American military planners. The M4 Sherman tank formed the backbone of every armored division. Yet it was meeting German tanks it simply could not destroy. Not from the front, not at reasonable combat distances. The Panther represented Germany's answer to Soviet tank superiority. It mounted a powerful 75mm high-velocity gun. More importantly, it protected that gun behind 80mm of steel plate. This plate wasn't vertical. It sloped at 55 degrees. This angle created effective thickness approaching 140mm. American tank guns couldn't penetrate it. Intelligence had failed catastrophically. Estimates suggested only a handful of Panthers would appear in combat. Reality painted a different picture. By June 1944, when Allied forces stormed Normandy's beaches, Panthers comprised 38% of German tank strength in the theater. Not dozens, hundreds. These advanced medium tanks rolled off production lines constantly. Many were crewed by inexperienced soldiers, young men with minimal training. But they sat behind armor that conventional American weapons couldn't touch. The 75mm M3 gun equipped most Shermans fighting in Normandy. Against Panther frontal armor, it was useless, completely ineffective. Rounds would strike the sloped glacis plate and ricochet skyward. Meanwhile, Sherman crews sat exposed to return fire. The Panther's gun could destroy a Sherman from over 2,000 meters away. American tankers called it murder. Even the improved 76mm M1 gun struggled desperately. This weapon began reaching units in July 1944. It represented a significant upgrade over the 75mm. Using standard M62 armor-piercing capped rounds, the 76mm could penetrate 109mm of armor at 1,000 meters. This assumed a perfect 90-degree impact angle. Against Panzer IV tanks, this was adequate. Against most German assault guns, it worked. Against the Panther's sloped frontal armor, it remained effectively useless. The 76mm could penetrate the Panther's gun mantlet, but only at extremely close range, typically under 100 meters. At such distances, the Panther's firepower advantage made engagement suicidal. Sherman crews had to close to point-blank range to achieve kills. Meanwhile, Panthers could engage and destroy them from 10 times that distance. The problem wasn't the gun mechanism itself. American engineering was sound. The problem was ammunition design. The deployment of 76mm guns had been plagued by bureaucratic delays and hesitation. The first Sherman tanks mounting 76mm M1 guns rolled off assembly lines in January 1944. Production was steady. Quality was high. These M4A1 76mm Shermans reached Britain on April 10, 1944. 130 tanks arrived to prepare for the invasion. Despite their availability, American commanders refused deployment on D-Day. Multiple factors influenced this decision. Crews lacked sufficient training time on the new system. Maintaining two different ammunition types complicated logistics. Supply chains would become more complex. Most critically, commanders believed 75mm guns would prove adequate. Expected German resistance seemed manageable with existing weapons. This calculation proved catastrophically wrong. By early July 1944, field reports from Normandy painted an increasingly grim picture. Tank crews were dying. Equipment was being destroyed faster than replacement could arrive. On July 2nd, formal complaints about 75mm gun ineffectiveness reached General Dwight Eisenhower. His response, documented in multiple historical accounts, revealed command-level frustration and anger. The exact words varied depending on the witness, but the message was consistent. Ordnance had assured him the 76mm would handle any German tank. Reality suggested otherwise. Eisenhower's anger was justified. American tank crews were paying with their lives for miscalculations made in Washington offices. A board convened on July 12, 1944. Its mission was to determine officially what frontline crews already knew through bitter experience. Standard American weapons could not defeat Panthers frontally. Period. General Omar Bradley immediately ordered all available 76mm Shermans rushed from Britain to the front lines. Speed was essential. American crews were dying daily. On July 25, 1944, during Operation Cobra, 102 M4A1 76mm tanks made their combat debut. The results were sobering but not surprising. While the 76mm represented improvement over the 75mm, it still struggled against Panther frontal armor at normal combat ranges. Sherman crews quickly developed new tactics. They learned to maneuver for flank shots. Side armor was thinner, more vulnerable. They targeted the Panther's gun mantlet at close range. Both options were tactically undesirable. Neither eliminated the fundamental problem. Panthers could destroy Shermans from 2,000 meters away. Shermans needed to close to under 500 meters for reliable kills, often much closer. The solution required advances in metallurgy and physics. By July 1944, American ordnance engineers had developed the T4 round. Later, it received the designation M93 HVAP, high-velocity armor. Piercing ammunition represented revolutionary thinking. Conventional armor-piercing design was abandoned entirely. The new projectile consisted of multiple components working together. A tungsten carbide core formed the heart of the system. This material ranked among the hardest substances available to wartime industry. Around this core, engineers placed a lightweight aluminum body. A ballistic windscreen completed the design. This configuration concentrated kinetic energy into the smallest possible point. The tungsten core was dense, extremely dense. The aluminum body was light, very light. Overall weight decreased while penetrating power increased dramatically. Results were spectacular. The M93 round achieved muzzle velocity of 1,036 meters per second. The standard M62 round managed only 792 meters per second. This 244 meter per second increase translated directly into penetrating capability. At 1,000 yards, approximately 914 meters, the HVAP round could penetrate 160 mm of armor at 30 degrees obliquity. Official War Department testing confirmed these figures repeatedly. Against Panther gun mantlets, this meant reliable penetration at ranges up to 1,000 meters. Early Panther models had curved 100 mm thick cast steel mantlets. Later G models increased this to 120 mm. Both could be defeated by HVAP rounds at combat ranges. The mantlet suddenly became a viable target. Sherman crews no longer needed desperate flank attacks. They no longer needed to retreat when Panthers appeared. But developing HVAP represented only half the challenge. Production was an entirely separate problem. The T4 round depended completely on tungsten carbide. This strategic material was imported primarily from China. Chinese mines produced 36% of global tungsten supply before the war began. Tungsten was critical to numerous war industries simultaneously. Machine tool production consumed enormous quantities. Armor-piercing ammunition for multiple calibers required tungsten. Armor plate hardening processes used tungsten. Various industrial applications competed for limited supplies. American tungsten demand for HVAP ammunition alone consumed hundreds of metric tons annually. Each 76mm HVAP round contained approximately 0.8 kilograms of tungsten carbide. A single Sherman carrying 6 rounds required nearly 5 kilograms of this scarce material. China produced approximately 10,000 metric tons of tungsten concentrates in 1944. This had to serve all Allied needs across all applications. The United States supplemented Chinese imports with domestic production. Colorado had limited deposits. Nevada contributed some production. California provided additional supplies. But total availability remained severely constrained throughout the war. Germany's tungsten position was far worse than America's. Swedish imports had declined sharply as the war turned against the Reich. Domestic German production remained minimal throughout the conflict. By 1945, German factories desperately hoarded tungsten for machine tools. These were needed for aircraft engine production. Meanwhile, Panther crews received only standard ammunition. No tungsten-cored rounds reached frontline units in meaningful quantities. The United States Ordnance Department had been testing HVAP projectiles since spring 1942. Laboratory work showed promise. Small-scale testing proved the concept. But production at meaningful scale did not begin until after the Normandy landings. Only then did the full extent of the Panther problem become clear to Washington planners. July 1944 saw initial production efforts begin. 3-inch HVAP rounds for tank destroyers reached 1,000 rounds total production. August yielded 1,000 rounds of 76mm HVAP. September produced another 1,076mm rounds. Production remained frustratingly low. Not until November 1944 did monthly production reach 5,000 rounds for the 76mm gun. January 1945 saw this increase to 7,000 rounds per month. By March 1945, approximately 33,000 rounds of 76mm HVAP ammunition had been manufactured. This represented significant industrial effort and resource commitment, but it remained a fraction of what battlefield conditions demanded. By February 1945, the average 76mm Sherman operating in Europe had received exactly 5 HVAP rounds. 5 rounds to face an enemy deploying Panthers as standard equipment in panzer divisions. A Sherman company with 17 tanks would possess 85 HVAP rounds total. They faced German units that might field 30 or more Panthers. The mathematics were sobering. Each Sherman would encounter multiple Panthers during combat operations. Each engagement might require multiple HVAP rounds to achieve kills. Supply would always be inadequate. The first HVAP rounds reached the European theater in August 1944. Their arrival coincided with broader tactical problems plaguing American armored operations. The Normandy hedgerow country had forced American armor into close-quarters combat. Visibility was limited. Maneuver was restricted. German defensive positions were expertly concealed. Superior German guns could ambush Sherman columns from prepared positions. Tank crews faced enemies who had learned to position Panthers in hull-down positions. Only the heavily armored turret remained exposed. The more vulnerable hulls stayed hidden behind earth berms or building ruins. German doctrine emphasized first-shot capability above all else. Panthers would wait in prepared positions. Sherman columns would approach unknowingly. German gunners would open fire from ranges where American return fire proved ineffective. The psychological impact on American tank crews became severe and measurable. Crews nicknamed the Sherman the Ronson lighter. They claimed it lit on fire every time someone pulled the trigger. While post-war analysis showed this reputation was somewhat exaggerated, the perception shaped battlefield behavior significantly. Tank commanders who spotted Panthers often chose to call for artillery support rather than engage directly. They requested airstrikes instead of fighting tank versus tank duels. This ceded tactical initiative to an enemy who could often be defeated with proper ammunition and tactics. The arrival of HVAP rounds began changing this psychological calculus slowly. Progress was hampered by ammunition scarcity and lack of training. Crews needed instruction on HVAP capabilities and limitations. Proper employment required understanding of effective ranges. Optimal targets needed identification. Ammunition conservation became critical given supply constraints. The first widespread combat test of HVAP ammunition came not in Normandy's restrictive hedgerow country, but in the more open terrain of Lorraine. There, American armored divisions had broken out into country that actually favored German defensive tactics. Rolling hills provided excellent hull-down positions. Long sight lines allowed German gunners to exploit their range advantages. Weather conditions often limited American air support. September 1944 found Lieutenant General George Patton's Third Army deep in eastern France. They were racing toward the German border with logistics stretched beyond reasonable limits. Fuel was running low, ammunition was rationed, spare parts were scarce. The 4th Armored Division, one of the most effective American armored formations, had advanced aggressively despite these constraints. They seized a bridgehead over the Moselle River near Aricourt. This position threatened German defensive plans. German High Command recognized the strategic threat immediately. If Patton's armor reached the Rhine River and crossed into Germany proper, the industrial heart of the Ruhr would be exposed to direct attack. General Hasso von Manteuffel's 5th Panzer Army received urgent orders. Counterattack immediately. Destroy the American bridgehead completely. Push back Patton's advance before it could threaten the homeland. The German force assembled for this attack included 2 newly formed panzer brigades. The 111th Panzer Brigade had just completed training. The 113th Panzer Brigade was equipped with Panthers fresh from German factories. Their crews were young, inexperienced, but they sat behind the best armor Germany could produce. Technical specifications seemed to guarantee victory. On paper, German advantages appeared overwhelming and decisive. The 2 brigades together fielded approximately 150 tanks and assault guns. Combat Command A of the 4th Armored Division possessed roughly 50 Sherman tanks. The 113th Panzer Brigade alone entered battle with approximately 90 armored vehicles in both battalions combined. This included 42 Panthers and 40 Panzer Rifles. Additional assault guns provided infantry support capabilities. German planners anticipated rapid victory. Panther technical superiority should compensate for any American advantages in logistics or air support. Intelligence suggested American forces were exhausted from their rapid advance. Supply lines were extended. Morale might be declining. The counterattack would catch them off guard and overwhelmed. They were fundamentally and catastrophically mistaken about every assumption. The Battle of Aricourt, fought over 11 days from September 18th to 29th, would become the largest tank engagement fought by American forces until the Battle of the Bulge 3 months later. More importantly, it would demonstrate conclusively that American tank crews, properly trained and equipped, could defeat technically superior German armor. Superior tactics mattered more than superior specifications. Combined arms coordination trumped individual vehicle performance. Judicious use of high-velocity armor-piercing ammunition could overcome apparent technical disadvantages. The morning of September 19th began with thick fog blanketing the rolling terrain around Aricourt village. Visibility dropped to less than 100 meters in many areas. German reconnaissance was severely limited by weather conditions. The panzer brigades, lacking proper scouting units due to rapid formation, advanced blindly into terrain held by American forces. American defenders knew the ground intimately. They had established defensive positions during the previous week. Observation posts were positioned on key terrain features. Artillery fire plans covered likely German approach routes. At approximately 8 a.m., elements of the 113th Panzer Brigade penetrated American outposts east and south of Eracourt village. The German tanks were factory-new Panthers with inexperienced crews. They moved forward in column formation. This represented a fundamental tactical error. Veteran American tankers immediately recognized the opportunity. Columns presented flank shots. Side armor was vulnerable. Proper tactics demanded immediate exploitation. Captain Kenneth R. Lamesson's C Company, 37th Tank Battalion, held defensive positions along key approaches to Eracourt. His Sherman crews had been carefully briefed on the HVAP rounds stored in their ammunition racks, 6 rounds per tank. Use them wisely. Target Panther turrets or mantlets at ranges where velocity remained sufficient for reliable penetration. Conservation was essential given limited supply. The fog that hindered German reconnaissance now worked decisively in favor of American defenders. A section of Lamesson's Shermans occupied concealed positions south of the village when the first Panther materialized from the gray mist. Distance was barely 75 meters. At this range, the Panther's superior long-range gunnery meant absolutely nothing. Surprise was complete. The American gunner fired instantly without hesitation. Training took over. The HVAP round, traveling at over 1,000 meters per second, struck the Panther's gun mantlet with tremendous force. The tungsten carbide core punched through the curved cast steel like it was paper. Inside the turret, the round detonated ready ammunition stored directly beneath the gun breech. The Panther exploded violently. Its turret lifted slightly from the hull due to the force of secondary detonation. Flames erupted from every hatch opening. 2 more Panthers emerged from the fog in quick succession. Both appeared within seconds of the first explosion. German crews had no time to process what was happening. Both were destroyed within moments. American gunners fired rapidly and accurately. HVAP rounds found their targets. More secondary explosions followed. More turrets separated from hulls. The remaining German tanks turned away immediately. Their crews were shocked by the sudden loss of 3 Panthers to what they had been assured were inferior American tanks. Throughout the morning of September 19th, similar engagements erupted across the entire Eracourt sector. American tanks used the fog as perfect concealment. They engaged Panthers at ranges where HVAP rounds proved most effective. Close range negated German advantages in long-range gunnery. Limited visibility prevented German crews from employing proper tactics. The battle became a series of point-blank duels, where American preparation and superior ammunition proved decisive. German tactical deployment proved disastrous from the beginning. Advancing in column formation without proper reconnaissance was suicide. Panther crews repeatedly exposed their thinner side armor to American flanking fire. Near Eracourt's command post, a platoon of M18 Hellcat tank destroyers joined the engagement. These vehicles also carried 786mm guns equipped with HVAP ammunition. The fast-moving tank destroyers proved devastatingly effective in close-range fog-shrouded combat. Their mobility allowed rapid repositioning between firing positions. By noon, as the fog began lifting gradually, American forward artillery observers could coordinate fire with defending tank companies. Visibility improved enough for proper fire control. P-47 Thunderbolt fighter bombers of the 405th Fighter Group arrived overhead right on schedule. They dove through gaps in the remaining cloud cover to strike German armor with rockets and machine gun fire. The combination of American advantages became overwhelmingly clear to surviving German crews. While the Panther possessed superior armor and firepower as an individual weapon system, American forces employed combined arms tactics as standard doctrine. This made all the difference in actual combat conditions. German tanks advanced without adequate artillery support. No air cover protected them from American fighter bombers. No infantry cleared American defensive positions before armor advanced. No reconnaissance identified American positions or strength. American forces coordinated armor with artillery support, air power, infantry, and tank destroyers in a fully integrated system. This coordination overwhelmed German technical advantages through superior battlefield management. When Panthers encountered these prepared combined arms defenses, they were destroyed piecemeal despite their superior individual capabilities. Technology alone could not overcome tactical superiority and better coordination. The HVAP ammunition did not make Sherman tanks equal to Panthers in pure technical specifications. But warfare is not conducted according to technical specifications alone. Battles are won by crews who identify and exploit enemy vulnerabilities under actual combat conditions. The Panther's gun mantlet, necessary to allow the 75mm gun to elevate and traverse properly, created a significant weak point. The junction between turret and hull offered another target. Side armor remained vulnerable throughout production. The engine deck could be penetrated from above. All represented targets that HVAP-equipped Shermans could now engage successfully at combat ranges that previously had been completely suicidal for American crews. More devastating to German morale than physical destruction was the psychological impact of discovering their armor was no longer invulnerable to American fire. Panther crews had received extensive training emphasizing their tank's superiority. Intelligence briefings repeatedly stressed Sherman inadequacy. Crews were explicitly told that as long as they kept their front armor toward the enemy, they remained completely safe from American guns. Survival depended on this simple rule. The first Panther commanders to watch Sherman rounds punch through their mantlets and detonate ready ammunition learned a very different lesson. Those who survived such encounters carried that terrifying knowledge back to their remaining units. Word spread quickly that American tanks now possessed ammunition capable of defeating Panthers frontally. The myth of invulnerability died in the fog around Aracourt. By the afternoon of September 19th, German tank commanders were sending increasingly frantic reports to higher headquarters. American Shermans possessed new, more powerful ammunition. The reports were confused and often contradictory. Some claimed Americans had secretly deployed tank destroyers mounting 90mm guns. Others suggested the British had provided 17-pounder Firefly tanks to American units without German intelligence detecting the transfer. The truth was more troubling to German planners than any of these theories. American industry had developed specialized ammunition that partially negated the Panther's carefully engineered armor advantage. This meant American industrial capacity could respond to tactical problems faster than German industry could develop countermeasures. The strategic implications were profound and deeply disturbing. Fighting continued through September 22nd, when major German offensive efforts finally stalled completely. American forces had destroyed or permanently disabled approximately 86 German tanks and assault guns. American losses stood at 25 Sherman tanks and 7 tank destroyers destroyed. The kill ratio heavily favored the Americans despite their apparent technical disadvantage in individual tank performance. Numbers told the story of superior tactics, better coordination, and effective use of specialized ammunition. The Battle of Aracourt represented not just a tactical victory for American arms, but a crucial psychological watershed in armored warfare. American tank crews learned definitively that they could defeat Panthers without waiting for specialized tank destroyer support or overwhelming air superiority. Proper ammunition, good tactics, and aggressive leadership could overcome apparent technical inferiority. German crews simultaneously lost the psychological security of believing in absolute frontal invulnerability. Their most advanced tank could be defeated by determined enemies with proper equipment. The German perspective on Aracourt was one of confusion, frustration, and bitter recrimination among surviving officers. The 113th Panzer Brigade, which had entered battle with approximately 90 tanks and assault guns in both battalions, could muster fewer than 20 operational vehicles by September 29th. Losses exceeded 75% in 11 days of fighting. Equipment that should have dominated the battlefield had been systematically destroyed by supposedly inferior opponents. German after-action reports struggled desperately to explain the comprehensive defeat. Panther technical superiority was undeniable on paper. Specifications clearly favored German equipment. How had inexperienced crews in newly produced tanks been defeated so thoroughly? The answers lay partly in training and combat experience levels. Panzer Brigade crews possessed minimal training on their equipment. Many arrived at the front with only weeks of instruction on complex systems. American tank crews in the 4th Armored Division were combat veterans who had fought across France since the Normandy breakout. They understood combined arms warfare intuitively and had learned to read terrain for maximum tactical advantage. But training differences alone did not fully explain the scale of Panther losses, particularly the frontal penetrations that should not have been possible with standard American ammunition based on German intelligence assessments. German intelligence officers examining destroyed Panthers found entry holes smaller than expected from 76mm rounds. This suggested subcaliber projectiles with dense cores. Examination of unexploded rounds recovered near disabled tanks revealed the complete truth that changed German strategic calculations. The Americans had successfully deployed tungsten-cored ammunition in frontline combat units. This discovery carried profound strategic implications far beyond the Ericourt battlefield. Germany had developed similar ammunition types, including the Panzergranate 40, which used tungsten cores to improve penetration against Soviet armor. But German tungsten supplies were critically limited by late 1944. Available tungsten was prioritized for machine tool production rather than ammunition manufacture. If Americans could field specialized tungsten-cored ammunition in quantities sufficient to distribute to frontline tank units, it demonstrated industrial capacity and strategic resource access that Germany simply could not match under wartime conditions. American tanks were not only more numerous and better supported logistically than German armor, but they were now equipped with ammunition that partially negated Germany's most carefully engineered technical advantages in armor protection. The implications would reshape German defensive planning for the remainder of the war in Europe. The effects of HVAP ammunition reached far beyond that single engagement at Ericourt. News traveled fast through American tank units. Stories spread from crew to crew. The word was out. The new ammunition could punch through Panther armor when everything lined up right. Tank crews heard these reports with growing excitement. For months they had felt helpless against German heavy tanks. The psychological weight had been crushing. Some units had developed what could only be called combat paralysis when facing Panthers. That crushing fear began to lift. Crews still knew Panthers were dangerous. They respected those thick armor plates and powerful guns. But helplessness was fading. Hope was returning. This shift in mindset proved more important than anyone realized at the time. A crew that believes it can fight will take risks. They seek good positions. They move aggressively when opportunities appear. They calculate odds and press advantages. A crew that feels outmatched does the opposite. They hesitate at critical moments. They give up initiative to the enemy. They fight defensively, even when attack would work better. HVAP ammunition was still desperately scarce. Most crews never got their hands on any. But just knowing it existed changed everything. Even tank crews who had never seen an HVAP round felt different about combat. The ammunition might arrive when they needed it most. That possibility alone boosted morale across entire armored divisions. Commanders faced impossible choices with their limited HVAP supplies. Every round had to count. Tank destroyers got priority allocation. Their whole mission focused on killing enemy tanks. They received the precious tungsten rounds first. Sherman tanks with their mixed rolls got fewer rounds despite meeting enemy armor more often. This created serious problems in the field. Tactical needs clashed with supply realities. The allocation system worked through multiple command levels. Orders flowed from Army headquarters down to battalion level. The system created inefficiencies at every step. Some lucky units received more HVAP than they could use immediately. Other units burned through their entire supply in days. Desperate requests for resupply went unfulfilled. The ammunition existed somewhere in the supply chain. Getting it to the right place at the right time proved nearly impossible. German forces launched their massive surprise attack in the Ardennes in December 1944. The Battle of the Bulge tested American tank units like nothing before. Hundreds of Panthers and Tigers rolled through snow-covered forests. Winter weather grounded Allied aircraft for days. American Sherman crews found themselves relying heavily on their scarce HVAP rounds. The shortage became critical within hours of heavy fighting. Some units exhausted their entire HVAP supply on the first day. Resupply requests disappeared into chaos. Snow blocked roads throughout the region. German advances cut supply lines. Ammunition trucks sat stranded or destroyed. Even urgent priority requests went unfulfilled. The harsh fighting in the Ardennes taught American forces valuable lessons. Technical disadvantages could be overcome through skill and coordination. Tank crews worked closely with infantry units. Bazooka teams crept close to disable Panthers from short range. Sherman tanks provided covering fire and suppressed German infantry. Artillery forward observers called in devastating time-on-target missions. High explosive shells could not penetrate Panther armor, but they damaged optics and observation devices. They broke tracks and road wheels. They killed exposed crew members. They made German tanks blind and immobile even when armor remained intact. Air support returned when weather finally cleared in late December. Fighter bombers proved devastatingly effective against German armor. Panthers concentrated on approach roads made perfect targets. Rockets and bombs shattered formations that had seemed unstoppable just days before. The Battle of the Bulge ended with German armored forces in ruins. Hundreds of irreplaceable tanks lay destroyed or abandoned. Experienced crews were dead or captured. The offensive had failed completely. Germany's last major attack in the West had collapsed. By early 1945, the strategic situation had changed forever. American and British forces prepared to cross the Rhine River. Soviet armies were smashing German defenses in massive winter offensives. Germany's industrial capacity was collapsing under relentless pressure. Strategic bombing had devastated factories across the Reich. Lost territory meant lost resources and manufacturing facilities. Critical materials like fuel and tungsten became impossible to obtain. Panther production had peaked at 3,900 units in 1944. By early 1945, production was falling sharply. Factories were bombed daily. Transportation networks lay in ruins. Raw materials simply did not exist. Even when Panthers rolled off production lines, fuel shortages often kept them immobile. German tank units in the final months frequently abandoned perfectly functional tanks, not because of battle damage, because they had no fuel to operate them. The technical limitations of HVAP ammunition deserved honest examination. The tungsten carbide core was excellent at penetrating armor under ideal conditions, but the material was inherently brittle. Below certain impact velocities, the core would shatter on contact instead of penetrating. That critical velocity threshold was approximately 2,300 to 2,500 feet per second. This meant HVAP effectiveness dropped significantly at longer ranges where velocity decreased. The effective range against Panther mantlets was roughly 1,000 meters. Beyond that distance, the probability of core shattering increased dramatically. American tankers learned these harsh limitations through combat experience. Sometimes the lessons came at terrible cost. Crews that fired HVAP at Panthers beyond effective range wasted precious ammunition. They often provoked return fire from German guns that remained deadly at much longer ranges. Training on proper HVAP employment was usually minimal. The ammunition arrived at frontline units faster than training materials could be developed and distributed. Many crews learned effective techniques through trial and error under combat conditions. The learning curve was steep and unforgiving. Sergeant Francis Baker experienced both the potential and limitations of HVAP during combat on November 20, 1944. His Sherman carried a 76mm gun loaded with HVAP rounds. The crew engaged a Panther at approximately 800 yards range. Baker's gunner fired 7 rounds at the German tank. Multiple hits were observed, striking the Panther's side armor. To Baker's frustration, every round bounced off without achieving penetration. The engagement demonstrated that even HVAP had significant limitations against sloped armor at oblique angles. The Panther eventually withdrew from the fight rather than continuing the engagement. The action was not a complete tactical failure, but it reminded Sherman crews that HVAP was not magical. Proper tactics remained absolutely critical. Careful shot placement was essential. Range estimation had to be accurate. Favorable angles of engagement were still necessary. HVAP gave American tankers much better odds than before, but success still required skill and good judgment under pressure. Post-war analysis of HVAP ammunition revealed both remarkable successes and serious limitations. Against Panther gun mantlets at ranges up to 1,000 meters, the ammunition was highly effective when hits were achieved. Penetration was reliable and often caused catastrophic secondary explosions inside the turret. Against the glacis plate, results were poor except at very close ranges and favorable angles. The extreme slope meant tungsten core rounds traveling at high velocity often ricocheted or shattered on impact. This meant Sherman crews still needed to maneuver for advantageous positions. Flanking Panthers remained the preferred tactic when terrain allowed. The ammunition did not make Sherman tanks technical equals to Panthers. But it gave American crews a real fighting chance in engagements where previously they had little hope of frontal penetration. The psychological impact of having that chance proved as important as the technical capability itself. The Korean War, beginning in June 1950, provided another combat test of HVAP effectiveness. American Sherman tanks, now primarily the M4A3E8 variant, armed with 76mm guns, faced Soviet-built T-34-85 tanks. Unlike the situation in Europe where HVAP had been desperately scarce, by 1950 tungsten supplies were no longer constrained by competing wartime demands. Substantial stocks were readily available to frontline units. American tank crews in Korea found that HVAP rounds easily penetrated T-34-85 armor at normal combat ranges. The T-34-85, while capable, possessed armor protection significantly inferior to German Panthers. Its 90mm thick turret front and 45mm thick glacis plate could not resist tungsten core projectiles fired at high velocity. American Shermans in Korea achieved remarkably favorable exchange ratios against communist armor. Superior crew training played a major role, but the plentiful availability of HVAP ammunition was equally significant. The vindication of the 76mm Sherman in Korea was bittersweet for veterans of European combat. The ammunition that could have been more widely employed in Europe proved devastatingly effective in Asia when supply constraints no longer limited its use. Many veterans wondered how different the fighting in Normandy might have been with adequate HVAP supplies. The German perspective on American HVAP ammunition, gathered from post-war interrogations and examination of captured documents, revealed grudging professional respect mixed with deep frustration. German ordnance officers recognized that American industry had solved the tungsten core ammunition problem more successfully than German manufacturers. This was particularly galling since Germany had pioneered the underlying technology. German forces had developed tungsten core ammunition with the Panzergranate 40 series. But production limitations meant these rounds were never available in sufficient quantities to influence battlefield outcomes. American production of HVAP, though also limited by tungsten scarcity, still exceeded German capability substantially by late 1944. German tank crews interviewed after the war frequently mentioned American ammunition improvements as a significant factor that complicated their tactical situation. The knowledge that Sherman tanks could penetrate Panther mantlets at combat ranges meant German crews could not simply rely on frontal armor for protection. This forced more cautious tactics and slower advances. Greater reliance on defensive positions became necessary. But defensive warfare ceded initiative to American forces. This allowed them to employ combined arms tactics that negated German technical advantages. The psychological impact of losing armor invulnerability contributed to the increasingly defensive mindset that characterized German armored operations in 1945. Technical analysis of HVAP projectiles recovered from German tank wrecks provided German engineers with detailed understanding of American ammunition design. The tungsten carbide core surrounded by lightweight aluminum body sections represented efficient use of scarce strategic materials. The design maximized penetrating power while minimizing tungsten consumption per round. The lightweight carrier body allowed higher velocities without excessive barrel wear. The dense tungsten core retained kinetic energy over distance far better than steel penetrators. German engineers recognized these advantages immediately, but they lacked the industrial capacity and material resources to respond with similar developments. By late 1944, German tank and ammunition production focused entirely on maintaining output of existing designs. Developing new ammunition types was not possible given the circumstances. Creating improved rounds would require tungsten Germany could not spare. Retooling would require factory modifications that plants struggling under constant air attack could not accommodate. German tanks in the final year fought with ammunition designs dating to 1942 and 1943. American ammunition continued improving throughout this same period. The technological gap widened steadily as American industrial capacity reached its peak. The Battle of Aracourt's historical significance extended far beyond immediate tactical results. The engagement proved conclusively that American armored doctrine could consistently defeat German tactical methods. American doctrine emphasized mobility and combined arms coordination. Superior logistics and overwhelming material support were central to the approach. German commanders had designed their 1944 Panzer brigades around Panther technical capabilities. They assumed armor thickness and firepower would compensate for inexperienced crews and limited support. This assumption proved catastrophically false when tested in sustained combat. The lesson was clear to military observers on both sides. Technical excellence in weapons design mattered and provided real advantages. But operational excellence in combined arms warfare mattered more. Superior logistics and better training proved more decisive for achieving tactical and operational success. The impact of HVAP on individual tank crews deserves consideration beyond purely technical analysis. For American tankers who had faced Panthers with only standard ammunition during the difficult Normandy fighting, the arrival of HVAP represented tangible hope returning to desperate situations. The ammunition did not eliminate the Panther threat completely, but it provided a tool that offered reasonable chances of achieving penetration under favorable circumstances. This psychological boost contributed to improved performance and more aggressive tactics across entire armored divisions. For German tankers, the knowledge that American tanks now posed a credible frontal threat fundamentally altered tactical calculations. Otto Carius, a highly decorated German tanker who commanded Tiger tanks and survived the war, wrote extensively about this in his post-war memoirs. Carius described the psychological impact of facing enemies who could penetrate previously invulnerable armor. The sense of protection that thick armor plates provided was crucial to crew morale and aggressive tactics. When that sense of security eroded, crew performance suffered measurably. Panther crews facing HVAP-equipped Shermans experienced exactly this erosion of confidence. The mantlet became a known vulnerability that competent American crews could exploit reliably. This knowledge made Panther crews demonstrably more cautious. They were slower to engage targets. They became generally less willing to take tactical risks that might expose the mantlet to enemy fire. The strategic implications of HVAP development extend to broader questions about technological competition in modern warfare. The crucial importance of industrial capacity over pure technical innovation becomes clear when examining this case study. Both American and German research establishments possessed competent engineers and sophisticated understanding of ballistics and armor penetration principles. Both sides recognized the value of tungsten core ammunition early in the war. Both developed functional designs that worked effectively when tested. The critical difference came down to industrial capacity and resource availability rather than scientific knowledge or engineering skill. American industry could produce HVAP in quantities sufficient to influence battlefield outcomes meaningfully. German industry could barely produce enough tungsten core rounds to conduct proper testing. This pattern repeated across numerous weapon systems throughout the war. Germany developed sophisticated and often technically superior weapons in many categories. But German factories could not produce them in quantities that affected strategic outcomes significantly. American industrial capacity produced less sophisticated but highly effective equipment in overwhelming numbers. The M4 Sherman was objectively not the best tank of World War II by most technical measures. But American factories produced approximately 49,324 of them, compared to roughly 61 and 32 Panthers produced by German industry. This 8-to-1 production ratio, combined with ammunition improvements like HVAP that reduced the technical performance gap, proved strategically decisive. Numbers and logistics trumped technical superiority when the gaps were not insurmountable. The post-war careers of veterans who fought at Eracourt reflect the enduring impact of these combat experiences on American military thinking. Lieutenant Colonel Creighton Abrams, who commanded the 37th Tank Battalion at Eracourt, with distinction rose to become United States Army Chief of Staff. The tank that bears his name, the M1 Abrams main battle tank, reflects lessons Abrams learned about combined arms warfare during World War II. The critical importance of crew training and the absolute necessity of adequate ammunition supplies influenced his entire career and the doctrine he helped develop. The M1 Abrams was deliberately designed with a powerful 120mm smoothbore gun and sophisticated ammunition types, including depleted uranium penetrators. These serve functionally the same role that HVAP served in World War II. The underlying principles remain constant across decades of technological development. German veterans of Panther units who survived the war and later joined the West German Bundeswehr brought different but equally important lessons to post-war military planning. They had personally experienced the limitations of possessing technological superiority without the industrial base and logistics to support it effectively. Bundeswehr armored doctrine during the Cold War emphasized quality and training while explicitly recognizing that West Germany could not match Soviet numerical superiority in tank production. But Bundeswehr planners informed by wartime experience also emphasized ammunition effectiveness as a critical factor. The Leopard 1 and later Leopard 2 main battle tanks used sophisticated ammunition designs informed by the hard-learned realization that ammunition technology and crew training mattered as much as armor thickness. Technical superiority meant nothing without the industrial capacity to produce and supply advanced weapons in adequate quantities. The conclusion of World War II in Europe, marked by Germany's unconditional surrender on May 8, 1945, ended the immediate tactical need for HVAP ammunition against Panthers. American ordnance officers systematically examined destroyed vehicles across the former combat zones. Clear evidence of HVAP penetrations appeared on some wrecks, confirming the ammunition's effectiveness under favorable conditions while documenting its limitations. Panthers hit by HVAP typically showed penetrations through the mantlet or turret face when struck at favorable angles. Penetrations through the glacis plate remained rare, which confirmed that this area remained highly resistant to tungsten core projectiles. This pattern validated American tactical doctrine that emphasized flanking maneuvers and creating favorable engagement angles rather than relying on frontal attacks. The comprehensive post-war analysis concluded that while HVAP meaningfully improved Sherman capabilities against heavy German armor, other factors remained more decisive. Overwhelming numerical superiority proved crucial. Vastly superior logistics made sustained operations possible. Complete air superiority after late 1944 was devastating to German armor. Superior artillery support and more effective operational doctrine combined to create American advantages that individual ammunition improvements could not match. HVAP was important but not decisive in the broader strategic context. The transformation of American tank crews from mid-1944 to early 1945 reflected the cumulative impact of multiple factors. Combat experience taught valuable lessons about German tactics and capabilities. Improved equipment availability meant more 76mm Shermans reached frontline units. Growing familiarity with specialized ammunition, including HVAP, boosted confidence. Crews that landed in Normandy in June 1944 often felt genuinely apprehensive about facing German armor, particularly Panthers and Tigers. The psychological weight of technical inferiority was crushing for many tank crews during the early phases of the Normandy campaign. By early 1945, after months of sustained combat and significant improvements in training and equipment, American tankers approached engagements with dramatically improved confidence. This psychological shift had direct tactical consequences that influenced every subsequent engagement. Confident crews fought more aggressively than demoralized ones. They took calculated risks when opportunities appeared. They exploited tactical advantages instead of hesitating at critical moments. While HVAP ammunition alone did not create this transformation, its availability and proven effectiveness contributed meaningfully to improved morale. The legacy of HVAP development continues influencing modern ammunition design in ways that demonstrate the enduring relevance of World War II innovations. American armor doctrine from 1945 onward consistently emphasized ammunition effectiveness as a critical component of tank design philosophy. Modern tank ammunition uses depleted uranium or tungsten alloy penetrators as standard. These materials are chosen for essentially the same density and hardness properties that made tungsten carbide effective in World War II applications. The underlying physical principles remain constant across decades of technological advancement. The goal remains the same: concentrate maximum kinetic energy into the smallest possible extremely dense projectile moving at the highest achievable velocity. The continuity from 1944 HVAP to present-day armor-piercing fin, stabilized, discarding sabot ammunition, illustrates how foundational lessons from World War II continue directly influencing military technology. Soviet and later Russian tank ammunition development followed remarkably similar paths. They independently recognized that armor-piercing capability depends heavily on projectile material properties and kinetic energy delivery rather than projectile size or explosive content. The global tank ammunition industry traces its technological roots directly to the HVAP experience. Engineers first demonstrated conclusively during World War II that specialized ammunition could partially overcome armor protection advantages through superior materials science and ballistics engineering. September 19, 1944, When First Lieutenant Melvin Mastern's Sherman crew first engaged Panthers with HVAP ammunition at Aracourt, marked a genuine turning point in the psychological balance of armored warfare. German crews who had fought confidently behind seemingly impenetrable armor learned that American tanks could pose serious frontal threats. American crews who had felt hopelessly outmatched gained meaningful confidence from knowing they possessed ammunition that could defeat Panthers under favorable circumstances. This shift in tactical psychology, enabled by tungsten core ammunition produced in American factories, influenced every subsequent armored engagement of the European War. HVAP ammunition, though never available in desired quantities, provided enough improved capability to transform American tank crews from uncertain defenders into confident attackers. They became willing to engage German armor directly instead of avoiding contact whenever possible. The crews who fired those first HVAP rounds in combat watched tungsten cores punch through armor that had seemed absolutely invincible. They demonstrated that industrial capacity and materials science applied intelligently to urgent tactical problems could overcome seemingly insurmountable technical disadvantages. This fundamental lesson learned at considerable cost on battlefields across Europe remains directly relevant for military planners facing technological challenges in modern warfare. Superior technology alone cannot guarantee victory without the industrial base to produce and supply that technology in adequate quantities to frontline forces.